In this video, I will talk about the Poisson distribution. We use the Poisson distribution when you are interested in the number of times an event occurs in a given area of opportunity. An area of opportunity is a continuous unit or interval of time, volume, or such area in which more than one occurrence of an event can occur. For example, the number of scratches in a car's paint, the number of mosquito bites on a person, the number of computer crashes in a day. The probability that an event occurs in a given area of opportunity is the same for all the areas of opportunity. The number of events that occur in one area of opportunity is independent of the number of events that occur in any other area of opportunity. The probability that two or more events will occur in an area of opportunity approaches zero as the area of opportunity becomes smaller. The average number of events per unit is denoted by the Greek letter lambda. So this is the formula for Poisson distribution. It's e to the negative lambda times lambda raised to the x divided by x factorial. X is the number of events in an area of opportunity. Lambda is the expected number of events. And e is the natural log base. So you can do this by hand, and you can also do it with technology. It's easier to do it with technology, but I'll show you how to do it by hand. So the mean of a Poisson distribution is lambda. The variance is also lambda, and the standard deviation is the square root of lambda. So let's look at an example. The mean number of customers who arrive per minute at a bank during the noon to 1 p.m. hour is 3. What is the probability that 2 customers arrive in a given minute? Okay. So in this case, x is equal to 2. Our lambda is 3. So what we can do is we can plug everything back into the formula. And as you can see, we get 0.2240 as the answer. Let's go ahead and try this with technology. Let's go ahead and use StatCrunch. So with StatCrunch, we're going to go to Stat, Calculator, and we're going to go down to Poisson. And then we're going to enter the mean. The mean in this case is lambda, which is 3. We want x equal to 2. When I hit compute, I get my answer, 0.2240. That's the same thing we got when we did it by hand. We can also use my template. The expected number, which is lambda, is 3, and my x is 2. If we look over here to the right, I have different probabilities. We want the probability that x is equal to 2. So x is equal to x. We want this one here, and as you can see, we get 0.2240. Okay, that's the same answer we got when we did it by hand. So there are other probabilities that we can calculate. Let's find out the probability that x is less than 2. What is the probability that fewer than 2 customers arrive in a given minute? So you really have to be careful with this. You have to be careful of the wording. So it says fewer than 2. So when we do this, here my pen out. This is the probability that x is 0 plus the probability that x is 1, because that's fewer than 2. We don't put the probability that x is equal to 2 because it didn't say to include the 2. It said fewer than 2. So you can do this by hand. The thing is, you have to do each one of these probabilities. So if I were to do each one of these probabilities, I have this for x is equal to 0, and I'll have this for x is equal to 1. Okay, when I calculate it out, I get these two probabilities and I add them up. I get 0.1991. So the probability that you get fewer than 2 customers is 0.1991. If you do it with StatCrunch, The mean is still 3. This time we want to change this equal to less than. And as you can see, we get 0.1991. If we do it with my template, I already have the numbers in there. We want less than 2, so we want this here. And as you can see, I get 0.1991. Okay? So, like I said, you can do it by hand, do it by StatCrunch, you can do it with my template. Let's look at another problem. What is the probability that 3 or more customers arrive in a given minute? Okay, so this is a little different. We want everything greater than or equal to 3. So we want the probability that x is equal to 3 plus the probability that x is equal to 4. But the thing is, this keeps going all the way out into infinity, and we surely cannot calculate this way by hand. So what you want to do is do the complement. So the complement of the probability that x is greater than 3 would be 1 minus the probability that x is less than 3. 1 minus the probability that x is less than 3. So to do this, this will be 1 minus the probability x is equal to 0 plus the probability that x is equal to 1 plus the probability that x is equal to 2. We do not include the 3 because it's less than 3. So we've already calculated it for 0 and 1. So I'm just going to go ahead and put these numbers in. And then for 2, I'll go ahead and put this in. It was 0.224042. Okay, so this is all in brackets. When I add everything up in the brackets, I get 0.423190. And when I subtract that from 1, I get 0.576810. Okay, so that's how you would do it by hand. Go ahead and do it with StatCrunch. So this time we wanted everything to be greater than or equal to 3. Our lambda is still 3. I'm going to change this less than to greater than or equal to 3. And as you can see, I get 0.5768. Same answer I got when I did it by hand. When I do it in my template, this time x is 3, so I'm going to change that to 3. My lambda is still 3. I want everything greater than or equal to 3. So I'm going to look at this one, and as you can see, I get 0.5768. Same thing I got when I did it with StatCrunch and by hand. That's the end of this video.